This is the solution to number 2 on the 2006 exam. Okay, so we're given a graph which is this function here, and they tell us that this is a rate. So we know that we're looking at a derivative because this is the rate. So we've got a certain number of cars per hour over the given time interval. Graph is shown above. Part A, we're rounding to the nearest whole number. We want the total number of cars turning left at the intersection from 0 to 18. Okay, so this here is the number of cars, or the rate at which the cars are turning left. So if we integrate that, that will give us the total number of cars. So part A, I want the integral from 0 to 18 of L of t, and you're going to put that in your calculator, and to the nearest whole number you should get 1658 cars. And we're ready for part B. So we've got traffic engineers considering turn restrictions when the rate at which cars are turning left is greater than or equal to 150 cars per hour. We want to find all values of t for which this inequality is true, and then compute the average value of L on this time interval. Okay, so we want to see where L of t is greater than or equal to 150. So here's 150. So we're looking for this x value and that x value. So the way we find that is we set L of t equal to 150. Now to solve that equation, again, you are using your calculator. And you should get 12.428 and 16.122. So that means that L of t is greater than or equal to 150 on this interval. Next part of the question, find all values of t. Oh, wait, we did that part. Now we want to compute the average value of L on this interval. So the average value of a function looks like this. So we're doing 1 over 16.122 minus 12.428 times the integral of L of t. And again, this is all going into your calculator, and you should get 199.426. And notice in the directions it says indicate units of measure. We've got to be careful to do that. And F is measured in, or L is measured in cars per hour. And finally, part C, we've got traffic engineers installing a signal if there's any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. And then they tell us that in every 2-hour time interval, that 500 oncoming cars travel straight through the intersection. So this means for part C, let's see, we get divide 200,000 by 500, and we're going to get 400. So that means that the number of cars turning left in a 2-hour period has to be greater than or equal to 400, which means that in a 1-hour interval, that the number of cars should be greater than or equal to 200. So I'm going to go up to my graph. Here's 200. And we want to find out what those values are there. So we're going to solve another equation using our calculator. We're going to find out when L of t is equal to 200, and that's going to happen in these two places. Oh, that's 15.324. So this means that during any 2-hour period between 13.253 and 15.324, they would need to have that signal put in. So we're going to say that. The number of cars turning left is greater than 400 during any 2-hour subinterval of that time frame there. And we can say, therefore, the traffic signal is required